Okay, so for these two questions, we are given this data. And what this problem is setting you up to do is hypothesis testing. This is a two-sample hypothesis test. If you look at 57, it's asking you what the test statistic is, and then 58 is asking you for the p-value. So what we're going to do is let's first figure out what kind of test we have. Is it a one-tailed test or a two-tailed test? We can figure that out by reading 57. So 57 says we want to determine whether or not there is a significant difference between the average salaries of employees at the two companies. So that means, I'm just going to put this right here. So our null hypothesis is going to be mu1, so mu1 minus mu2 equals 0. Our alternative is going to be mu1 minus mu2. Let's do this for does not equal and 0. So this means we're looking at a two-tailed test. So if we go to our cheat sheet, this matches up with this top case right here. Okay. Now let's try to calculate the test statistic, because that's what this first question is asking. So we need to do x bar 1 minus x bar 2 divided by this standard error. So my N1 is 72. Sample mean, so x bar 1, that's going to be 48. Population standard deviation, so I'm just going to put POP for population, then standard deviation 1, that's going to be 12. And then we have N2. N2 is 50. What is x bar 2? X bar 2 is going to be 43. Then we have population standard deviation 2, and that's going to be 10. Okay. Let's first calculate the standard error, because that's kind of a big formula in this test statistic. And I think it's going to be easier once we have that to do the test statistic. So it's where it's going to be the square root of standard deviation 1 squared divided by N1 plus standard deviation 2 squared divided by N2. So I'm going to square these two values, these two standard deviations, just right here, again, to make it easier in the formula. Okay. So that's going to be 12 squared, and it's going to be 10 squared. Okay. So now let's do the standard error formula. So that's the square root of this value divided by this value. So population standard deviation 1 squared divided by N1 plus population standard deviation 2 squared divided by N2. And do that. That's our standard error. Now let's get our test statistic. Let's do that formula. So it's x bar 1 minus x bar 2 minus value. The value for these types of problems, for chapter 10 problems, is just going to be 0. It also relates to this. So it's 0. So we don't have to worry about that. So x bar 1 minus x bar 2 divided by our standard error. So let's write test stat. So x bar 1 minus x bar 2. Make sure you have the parentheses. And you want to divide that by the standard error. So when you do that, you get your test statistic of 2.5. So that's this one. Okay. Now we need to get our p-value. So this is a two-tailed test. Let's go down to our p-value approach. Do we have population standard deviation or sample standard deviation? You can see right here we have population standard deviation. Because we have population standard deviation, we are going to be using this top part, right? when population standard deviation is known. So the stuff in purple. This is a two-tailed test, meaning we're going to be using one of these formulas. Is our test statistic positive or negative? Our test statistic is a positive 2.5, meaning we're going to be using this one right here. So 2 times 1 minus norm.s.dis, test statistic, comma 1. So let's do that right here, our p-value. So we said it's going to be 2 times 1 minus norm.s.dist, test statistic, comma 1. And make sure you have the parentheses there. And there's our p-value. And since our p-value is less than alpha, our alpha is 0.05, we're going to say we reject. And so looking at our p-value here, this matches with this p-value, this answer choice right here. So this is going to be our answer.